Let's look at one example here, one application. We are given a population function for the population of a culture of cells. Now, because of the limited space, the population of the cells will not grow indefinitely, so it will increase, but eventually it will also approach a constant level, and this constant level is called a steady state or a carrying capacity. And obviously from the graph you can see that the population growth is increasing, but eventually it's approaching so-called steady state. So the first question here we have is, what time is the instantaneous population growth rate the greatest? So we are talking about instantaneous population change, right? So when you hear the instantaneous, the growth rate change, that means you need to find the derivative. And we need to figure out the time the derivative achieves its highest number. Geometrically speaking, the derivative means the slope of tangent line. So basically, if you look at the graph, we are looking for a time that the derivative, which means the slope of tangent line, is the highest. So you can see that that it's somewhere the growth rate here, the tangent line is not as steep, and when its time is increasing, the slope is also increasing. At some point somewhere here, it starts to decrease again, right? So somewhere here, that would be our answer. So let's do it using the algebra or calculus that we learned. So the first thing that we need to do is to, let's zoom in, let's find the derivative of the population, so p prime of t. Now if you look at your function, you should use your quotient rule, right? So let's use quotient rule. This is going to be equal to, so low square 1 plus 3 times e to the negative 0.5 t square. The top is low d high, so it's low, which is 1 plus. By the way, low d high, because the derivative of the high is going to be 0. I know the low d high will be 0, right? Minus, because 400 is constant, derivative of the top is going to be 0. Minus high d low, which is 400 times the derivative of the bottom function, which is negative 3. So negative comes from the power coming from the negative 0.5, negative 3 times 0.5, e to the negative 3, e to the negative 0.5 t. Now this is equal to, after this algebra, you see that this 0.5 times 400 is 200, 200 times 3 is 600, and negative sign, you get positive sign. So it's 600 e to the negative 0.5 t. The bottom is 1 plus 3 times e to the negative 0.5 t square, right? Okay. Now, actually, in this case, for this particular function, to find, so we need to figure out when this guy is p prime is highest, okay, highest. In other words, you're looking for the maximum. This is one of the most important topic in calculus. However, we are not able to, that will be introduced, the skill will be introduced actually in chapter 4. So for now, we are gonna just say, for now, only for now, we're gonna just say, hey, how about we kind of eyeball it. So just take a look at the graph. Seems like somewhere here the slope of the tangent line is highest, because after this point it's getting flatter and flatter. Before this point it's still from flat to increasing, right? So somewhere here is the highest point. So for now we're gonna say use graph. Basically you eyeball the steepest tangent line occurs at around t close to 2.2 unit time. Okay. Again, in the future to find exact time, in the future we need to do this. We need to find the double prime and then set that to 0. This will be introduced in chapter 4. Okay, so for now we're going to skip that. Actually, after using this one and solve for t is about 2.19722, just for your information. Okay, but we are not going to touch that too much at this point. So what is the steady state population? That means if we look at the graph, that means, hey, when time is approaching infinity, what is this population is approaching? That's what we are trying to do. Basically, that means when time is approaching infinity, what is this function approaching? So it's basically the limit t approaches infinity, this function, which is 400 over 1 plus 3 times e to the negative 0.5t. Now, when t is approaching infinity, that means we are looking at e to the negative infinity, right? And this is the same as 1 over e to the infinity, which is 1 over a huge number, which is approaching 0. So therefore, we know this guy is approaching 0 when t is approaching infinity. So it will be 400 over, the bottom is just 1, so it's 400. And the graph also verifies the answer. The 400 is the answer.